Hi everyone, today we're starting chapter 4 and in this unit we will be dealing with quadratic functions. Today we're going to be talking about graphing them. Our objectives for today are that students will be able to graph quadratic functions and you will be able to find and interpret the maximum and minimum values of a quadratic function. Let's get started. Alright, when we're dealing with quadratic functions, it's important that we know what is the standard form of a quadratic equation. So the standard form of a quadratic equation is y equals ax squared plus bx plus c. All right, where a and b are coefficients of x squared and c is a constant. Okay, then a quadratic equation will always create a U-shaped curve, and I'm pretty sure you guys have seen this word before, but that U-shaped curve that a quadratic function makes is called a parabola. So for example, if we have the graph of a quadratic function, it's always going to look like this. It's always going to be U-shaped and it's going to be called a parabola. And of course I had to throw this little meme in there. So what's a group of parabolas called? Parabolums. All right, either think it's funny and laugh or think I'm weird. I know some of you do. All right, moving on. All right, so some examples. If we were to graph each of these quadratic functions using a graphing calculator or using Desmos, I'm going to just give you a rough sketch of what they would look like. So starting with this first quadratic function over here. If we were to graph this in Desmos, it would look something like this. Okay, so it would be a U-shaped. It would cross the x-axis right about here and right about here, and it would have a point at the bottom. All right, so when a is positive, here our a is positive 1. All right, we know that it's going to open up. Over here, we've got a quadratic function, and a is negative 1. All right, and if we were to graph this using Desmos or a graphing calculator, it would look something like this, okay, where we've got a point up here, crosses the x-axis twice, and it's pointing down. So when a is negative, it's going to be pointing down. When a is positive, it opens up. When a is negative, it opens down. All right, and for those of you who want an exact sketch, here's what the first one looks like when we plug it into Desmos. All right, it is opening up. It's got a y-intercept of -5, crosses the x-axis at -3.45 and 1.45. All right, and then our second one, this is a more accurate visual of what this one looks like. A is negative, so we know it opens down, and that's what I want you guys to see in these, is that if A is positive, it's going to open up. If A is negative, it opens down. All right, now we've got different parts of a parabola, and we're going to give them special names. So if we were to draw a vertical line that divides the parabola into two equal parts, we call this the axis of symmetry. So for example, on this graph right here, the vertical line that would divide this graph in half would be right there. And that would be our axis of symmetry, okay? And to find the axis of symmetry, we use a formula. And the formula to find the axis of symmetry is x equals -b over 2a. And we have to use our standard form. We know what a is. It's ax squared plus bx plus c. So b is that coefficient in front of x, and a is the coefficient in front of the x squared. All right? Now, the turning point of a parabola is called the vertex. So in this graph right here, this would be the vertex, 1.5, 9.25. That is the turning point. And when the vertex is at the lowest point, it's called a minimum. And when it's at the highest point, it's called a maximum. So for example, our vertex right here would be the maximum because it's at the highest point of the parabola. If our parabola looked like this, okay, then the bottom would be the vertex, all right, and that would be the minimum. So if our parabola was opening up, if our quadratic function is positive and it's opening up, we have a minimum. If our quadratic function is pointing down, we have a maximum. All right, and we just label the parts on this graph right here. We don't need to do it for the other one. All right, I just want you to be able to see the difference between maximum and minimums, the turning point is called the vertex, and identify that axis of symmetry. All right, so with number 1, we want to determine whether each function has a minimum or maximum. Then we want to find the axis of symmetry and vertex, okay? So first of all, let's zoom in on this a little bit. We know we've got f of x equals 4x squared. Now we know a is positive, so no matter what, we know our graph is going to be opening up, all right? That means we have a minimum. Our vertex is on the bottom. So we have a minimum because our parabola is opening up because it's positive. All right, because a is positive. Now to find the axis of symmetry, we need to use our formula. X equals negative b over 2a. Now because there's no b, we just assume this is plus 0x plus 0. All right, so b is 0. So we would say that x equals negative 0 over 2 times, and our a is 4. All right, because a is always that coefficient that comes in front of x squared. So then we're just solving here. We've got x equals 0 divided by 8. 0 divided by anything is 0. So the x value, our axis of symmetry, would be 0, but it has to be a line, and we know it's a vertical line. So our axis of symmetry would be the line x equals 0. All right, now if we wanted to find the vertex, the axis of symmetry is always the x value of our vertex. So we know that our vertex is going to be 0, something. Okay, so our axis of symmetry is always the x value of our vertex. Now we need to find the y value. So in order to do that, we want to take our original quadratic function, and plug 0 in for x. So we would say y equals 4x squared, and we plug in 0 for x. Now y equals 0. So the y value of our vertex is 0. So our vertex is 0, 0. And we just found whether or not it has a minimum and maximum, our axis of symmetry, and our vertex. All right, number 3. First thing we want to identify is we know that a is negative, so it's going to be a parabola that's pointing down. Therefore, we have a maximum. Our vertex is on the top. So we have a maximum because a is negative. Then if we want to find our axis of symmetry, we want to use the formula x equals negative b over 2a. Now, something I want you to be careful about here is that right now, this is in standard form, but we're missing something, all right? Because standard form is y equals ax squared plus bx plus c, where c is a constant, okay? Now, we're missing a bx here. We've got our constant is 7, and ax squared is negative 2x squared, but we're missing bx. So we have to be sure to remember that this is plus 0x plus 7. So therefore, our b would be 0. So we put a placeholder 0x in there to remember that b is 0. So to solve for our axis of symmetry, we know x equals negative 0 over 2 times, and our a is negative 2. To solve for this, we continue. We would say 0 over negative 4. So x equals 0, and that is our axis of symmetry, because our axis of symmetry has to be a vertical line. So it is x equals 0. We have to say x equals 0, because an equation of the line that's a vertical line has to be x equals a number. Now we know our axis of symmetry, that is going to be our x-coordinate of our vertex, but we need to find the y-coordinate of our vertex. So we take our original quadratic equation, y equals negative 2x squared plus 7, and now we want to substitute 0 in for x. So we get y equals negative 2 times 0 squared plus 7, and we solve for y. So we keep simplifying. We know we get 0 plus 7 here, so y equals 7. So the y-coordinate of our vertex is 7. Therefore, our vertex is 0, 7. And we're done. Now we want to graph quadratic functions using a table. So how do we do that? First thing we want to do is find the axis of symmetry and the vertex. All right, we always want to find our axis of symmetry and our vertex first. Then we're going to place the vertex in the middle row of our table. Then we pick numbers bigger, numbers smaller, and complete our table. Then we want to graph all the points from our table. All right, we also want to be able to identify the domain and range of each quadratic function as well. Let's do a couple examples. All right, so number 5, we're given our function f of x equals negative 3x squared. So first thing we want to do is identify our axis of symmetry. So we're going to use the formula, x equals negative b over 2a. Now, this right here, if it's in standard form, remember this is plus 0x plus 0. All right, so our b is 0. So to find our axis of symmetry, plug in 0 for b over 2 times a, and we know a is negative 3. So we simplify and we get x equals 0 divided by negative 6. 0 divided by anything is going to give us 0. So the x value of our vertex and our axis of symmetry is x equals 0. Then we want to find the y value of our vertex. So we take our original quadratic equation, y equals negative 3x squared, and we want to substitute 0 in for x. So we get y equals negative 3 times 0 squared. Therefore, y equals 0. So our vertex is 0, 0, and that's going to go in the middle row of our table. So we plug in 0, 0, in the middle row of our table because that is our vertex. Then we want to pick 3 numbers smaller. So we pick negative 1, negative 2, negative 3, 1, 2, and 3. Then we want to take each of these values and substitute them in. So we take negative 3 and plug it in for x. Negative 3 squared gives us positive 9 times negative 3 gives us negative 27. All right, so this is going to be negative 27. And if we plug in negative 2 for x, negative 2 squared gives us positive 4. Positive 4 times negative 3 gives us negative 12. Plug in negative 1. Negative 1 squared gives us positive 1 times negative 3 gives us negative 3. We already know 0, 0. Plug 1 in. 1 squared gives us 1 times negative 3 gives us negative 3. Plug 2 in. 2 squared gives us 4. 4 times negative 3 is negative 12. Plug 3 in. 3 squared is 9. 9 times negative 3 is negative 27. All right, now we've got all of our ordered pairs, so we want to graph them. We know we're going to have a point at 0, 0. Then we know we've got negative 1, negative 3, positive 1, negative 3. Then the rest of our points will go off the graph, right? 2, negative 12 will go off our graph, and especially 3, negative 27 will go off our graph. But we have an idea of what our graph looks like, so that's enough points. Then we want to connect them and make sure it looks like a parabola. We know it's going to be going down like this. And there is our graph of this quadratic function. Now our domain, just like with absolute value, same with quadratic, our domain is always going to be all real numbers. All right, so the domain of this quadratic function and all quadratic functions is all real numbers from negative infinity to positive infinity. Now our range. Range, we always think bottom to top, y-axis, we know it goes down forever, but then it stops at 0. So our range would be from negative infinity to 0. And we're done. All right, number 7. First thing we want to do is find the axis of symmetry and the vertex. So start with our formula for axis of symmetry. X equals negative b over 2a. We know our b is negative 8 and our a is 2. So we plug those in. X equals negative b. Now we plug in b using parentheses. So you got to be careful here. It's negative 8. All right, so be very careful when you're plugging in b. Over 2 times a. We know a is 2. So we simplify this. We get positive 8 on top because a double negative makes it positive, divided by 4. So x equals 2. So we know our axis of symmetry is x equals 2. And the x value of our vertex is 2. Now we want to find the y value of our vertex. We've got to plug it back into our original quadratic equation. Our original quadratic equation is y equals 2x squared minus 8x plus 6. So we plug in 2 every time we see an x. So y equals 2 times 2 squared minus 8 times 2 plus 6. All right, give ourselves a little bit more space here. So y equals, we do exponents first, so we get 2 times 4 minus 16 plus 6. Y equals 8 minus 16 plus 6. Y equals negative 8 plus 6. Y equals negative 2. All right, so the y value of our vertex is negative 2. And now we've got our vertex. So the next thing we want to do is we want to fill in the rest of our table. So we pick 3 numbers smaller and 3 numbers bigger. So 1, 0, negative 1, 3, 4, and 5. Now we plug in all these numbers. So if we plugged in negative 1 here, we can do it by hand or use a calculator. When we plug negative 1 in, we're going to get 16. When we plug 0 in, we get 6. When we plug 1 in, we get 0. When we plug 3 in, we also get 0. When we plug 4 in, we get 6. And when we plug 5 in, we get 16. All right, so now we've completed our table, and now we want to graph. So start with our vertex. 2, negative 2. There's our vertex. Then we know to the right, we're going to go 3, 0, 4, 6. All right, and 5, 16 would go off the graph, so we don't need to worry about it. Then to the left of our vertex, we've got 1, 0, 0, 6, and negative 116 would go off of our graph, so we don't worry about it. Connect our dots and make sure our graph looks like a parabola. And there is our quadratic function. We graphed it. Now, identifying our domain is always all real numbers from negative infinity to positive infinity because it goes left and right forever. Now, our range. We know it goes up forever, but it doesn't go down forever. It starts at negative 2 and it goes up forever. So our range would be from negative 2 to infinity. And we're done with this one. If you have any questions, call me over so I can help you. Otherwise, let's move on to our final example. All right, I want you guys to try number 9 on your own. Find your axis of symmetry and vertex, fill in your table, graph it, and identify the domain and range. When you come back, I'll have the answer written on your screen and we'll go through it together. Do not be intimidated by fractions, okay? It's okay to have fractions. You can write them as decimals or fractions as long as they're equivalent, okay? Don't let the fractions intimidate you. So go ahead and give this one a try. When you come back, we'll go through it together. Pause your video now. All right, so you should have first started by finding the axis of symmetry. X equals negative b over 2a, your b is negative 1, your a is negative 1/2. You simplified and you got that x equals negative 1. So that would be your axis of symmetry. Now that is also the x value of your vertex. We take the original quadratic function, plug x in, and solve for the y value of our vertex, and we get that y is 1/2. So we put our vertex in the middle row, pick 3 numbers smaller, 3 numbers bigger, then we take each of these x values and plug them back into our original equation. Every time we see an x, we plug in negative 4, and we get negative 4. Every time we see an x in our original function, we plug in a negative 3, and we get negative 1/2. Every time we see an x in our original equation, plug in negative 2, and we get 0. Plug in 0 and get 0, 1 and get negative 1/2, plug in 2 and we get negative 4. Plot all of our points, connect our dots, and we know it's a parabola that should be opening down because we have a negative a. And there's our graph. Domain is all real numbers because it goes left and right forever. Range, we know it goes down forever, but it doesn't go up forever. It stops at y equals 1/2. So we say from negative infinity to y equals 1/2 to 1/2. And that is our range. All right, if you have any questions about graphing these quadratic functions using a table, be sure to call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.